6.4 part 3 is on logarithmic differentiation. Okay, so we've talked a little bit about some strange derivatives that you're supposed to memorize, right? We've talked about, like, if you have y equals a to the x. So, for example, like y equals 5 to the x, we've talked about its derivative, which is 5 to the x times natural log of 5, right? We've talked about if we have x to the n, it's n times x to the n minus 1. But we've never done anything that's like x to the x, right? You can do derivatives of things that are like x to the x, but you do it with logarithmic differentiation. So this is kind of a weird thing. All right, so number 1, notice that we have y equals x to the 2/3 times the square root of x to the 4th minus 1 over 5x minus 1 cubed. Yeah, that's product rule, that's chain rule twice, it's quotient rule. Woo-wee! Don't want to do it, do ya?
Cross it out.
Nope, we're not crossing out and moving on because I'm going to teach a shortcut. It's very exciting. All right, it's called logarithmic differentiation. So what we're going to do is when we have lots of powers and things like this, we're going to take the natural log of both sides. Because we like logarithms. Logarithms are very nice to us. All right, because now, since I have a log of a bunch of junk, right, remember I can do natural log of x to the 2/3 plus natural log of the square root of x to the 4th minus 1 minus the natural log of 5x minus 1 cubed. Do you understand that? That's like these rules.
Yeah.
AB equals natural log of A plus natural log of B.
So you're just...
And then it's like this rule. Whoops. Natural log of A over B. Natural log of A minus natural log of B. I'm using those rules. Do you guys see how I did that? What about powers?
You can put them in the front.
Yeah, so this 2/3 is now going to go to the front. This is a 1/2 power, right? It's going to go to the front. So we're going to have we're going to have 2/3 times the natural log of x plus 1/2 times the natural log of x to the 4th minus 1 minus 3 times the natural log of 5x minus 1. Okay. But the whole point of this is to be able to take a derivative, and I still haven't even taken a derivative. I've just simplified things. So now I'm going to take the derivative. Right? What's the derivative of natural log of x?
1 over x.
1 over x. Good job, Hannah. I bet you made flashcards, didn't you? You're going to take the derivative of natural log, which is actually really easy because it's 1 over x. So I'm going to have 2/3 times 1 over x plus 1/2 times 1 over x to the 4th minus 1 times, don't forget your chain, 4x cubed minus 3 times 1 over 5x minus 1 times 5. Good. So I took the derivative of the right side, but what about the derivative of the left side? 1 over y dy over dx. Good. Hannah gets the point. Bob does not get a brownie point, not an actual point. Brownie point. Why do you have to do the derivative of the left side? Because we did the derivative of the right side, so we're just keeping these down. We're doing derivative of both sides.
Okay, but like when we did that only for logarithms, because when we were just doing like regular derivatives.
Yeah, because we're trying to find what dy over dx is.
Okay.
So we hadn't taken a derivative yet, so we just did the derivative of both sides at once. It's kind of like, I mean, even if you have like this, right, we do y prime, that's dy over dx. You do the derivative of both sides. Okay, almost there. Okay, we need to solve for dy over dx. What do we do? Multiply both sides by y. Good job, Sai. Multiply both sides by y, right? dy over dx equals y times, and then we just clean it up a little bit. So it's going to be 2 over 3x plus 1 over 2 times x to the 4th minus 1. Oh, I forgot I had my 4x cubed, right? 4x cubed, so I'm going to reduce and have a 2x cubed on top. You know why. And then minus 15 over 5x minus 1. Parentheses.
Try in, I guess, the third where you have the 2/3 times 1 over x. Is that just the rule to put the 2/3 like that? Like, why don't you change the 2/3?
Because if I have like y equals 2/3 natural log of x and I want to find the derivative, you could do product rule. Like you could have 2/3 times the derivative of natural log of x plus derivative of 2/3 times natural log of x. But we don't do that 0 part because it's just going to be 0 anyway. Is that what you're asking? Okay. Yeah, Leonie?
Why would you be, so like, for the bottom part, for the denominator, is it supposed to be 2 times x to the 4th minus 1?
2 times, oh, it was 2 and then parentheses x to the 4th minus 1. But we had a 4x cubed on top, so I was saying reduce that out. So like reduce by 2.
So you went,
So there's the 2. It's just kind of messy. All right, now with logarithmic differentiation, this is your answer. Like you can leave your answer like this, or you can plug in y. Do you guys see how we have like just a y? What was y? It was all this nastiness. Like you can plug that in here for y. Why would you do that, right? You can. So just know your answer may have that in there, okay? You don't have to. All right, for the most part, if something's really easy, like x to the x, I'm going to plug it back in. If it's not easy, I'm just going to leave it as y. Yeah?
So if they plug that back in, like, on the KP, multiple choice test, would they, like, do a weird thing and, like, try and...
Probably not. They probably wouldn't do that too much. They might, for these ones, a lot of times this is, like, evaluated at x equals whatever, you know? So, like, you would plug in x in the end and you just get a number. Because these can be really, really messy. So, and it'd be hard to fill up. Can you imagine like the multiple choice, like having this long of an answer for A and another long answer for B? Like they don't typically do that. Yeah. All right, next one. Same idea. Whoops, did I skip a page? No, there we go. All right, so y equals x to the square root of x. So this is when you should recognize that you need logarithmic differentiation. So if it looks so complicated that you're doing like the last one, product rule, chain rule, quotient rule, and you're like, right, try logarithmic differentiation. If you see something like this, the reason you know is because it's not x to a number, and it's not a number to x, right? It's like x to something with x. That's when you know you have to do the logarithmic differentiation. And there's one like that on your quiz, or not your quiz, your study guide. All right, so I'm going to have natural log of y, and I'm going to have natural log of x to the square root of x. So we pull it to the front. So we're going to have natural log of y equals the square root of x times the natural log of x. Yes?
When you have the square root of x, can't you, before you do the natural log stuff, can't you, like that's x to the x to the 1/2. And so you can multiply those, so you just get 1/2 x.
Okay, I see what you're saying. Like you're saying it's like that.
Yeah.
Can you bring a 1/2 to the front? No, because it would need the whole power.
No, like
Yeah.
when powers are multiplied, one power is power is multiplied. That's x to the 1/2 x.
Oh, yeah. I see what you're saying. So like what we were doing the other day when I showed you that one that was like 4 cubed, like that, like 4 to the 3x, and I had you write it as 4 cubed to the x. Yeah, you could do that. But then you would still have the problem like, yeah, you can do that, but then you still have the x to the x thing. It's still not removing the problem, you know.
I was talking about like so 1/2 x.
1/2 x.
Like that'd be x to the 1/2 x. But not
X to the 1/2 x.
yeah. Is that
I don't think so. I'm confused.
well, no, it's when you like that's multiplying x
Okay.
No, but when you
Like you're saying here.
exponent, it has to be the square root.
Like you're saying x to the x over 2, basically.
Yeah.
Is that what you're saying? Yes, you can do that. Correct. Gotcha. Do you guys understand what he's saying?
Oh, like when you have like 3 and then 4.
Yeah.
So he's noticing that he has that. So it's x to the, yeah, so you're basically multiplying these. Like you're thinking of this and then you're multiplying here. Is that right? I don't know. Let me think about that a little bit. Okay, I'll think about it. All right, so anyway, so if we do this way, so we bring the one, like the square root of x to the front. Then when we do the derivative, I'm going to have the square root of x times 1 over x plus the derivative of the square root of x. Do you guys know that off the top of your head now? Exactly. And then times the natural log of x. Oh, and that's not natural log of y. It's 1 over y dy over dx.
Why is all the plus 1/2 there?
Product rule. Right? This and this.
Oh, gotcha.
All right, so I have 1 over y dy over dx equals, and I'm just going to clean it up a little bit. I have square root of x over x. I mean, you can leave it like that. You can have it as 1 over the square root of x. I don't care. It doesn't matter. So then you have natural log of x over 2 square root of x, like that. Now, what your AP test probably will do, like if this was an answer, is they would probably get common denominators because they're jerks. They would do that. So do you see how you have this and how I was saying you could write it like this? Do you guys see how that's equivalent? Because you have the square root of x over the square root of x times the square root of x is x. Cancel, cancel. 1 over root x. So they would multiply by 2 over 2. And so they would probably have their final answer as 2 plus natural log of x over 2 root x times y equals dy over dx. Yeah, that's what I'm saying. Like the natural log problems can be really terrible. Now, what can you do as a good test taker? Some of you guys are really good test takers. If you get an answer, like you're looking at your multiple choice and you're like, oh my gosh, I don't know which one is my answer. What can you do to see if yours is the same as another one? Plug in what? Anything, right? Plug in, probably not 0 because it's natural log, right? Hitting natural log of 0, but maybe like 1, right? Eliminate choices and then plug in E, right? Eliminate choices, right? I would do that. Yes?
I did not get the same thing.
You did not? Yeah, I was wondering with your x to the, I got to think about that a little bit.
I got y.
I don't think that's true.
Over 2.
Okay, I'll play around with it. Yeah. So, but we're talking about like, he's talking about the debate. We had 4 to the 3x the other day. So he's saying we rewrote it as 4 to the 3 to the x, like that. But I think the problem is it was like, this was 3 to the x. Do you know what I'm saying? It's not the same. Like 4 to the 3 to the x is not the same as what we were doing the other day. That's why I was saying I need to think about it and write it down, because I was like, I don't think that's right. Yeah.
We had that like number 2 on the homework where the derivatives of into the x and that's the log of x. So what are we supposed to?
No, you had an e to the square root of x. Different.
So is that like completely different from this?
Yes.
So
E is a number. X is not a number.
for that one, could you have raised? Because like for that one, that's what I did. I did.
So Hannah's asking about this. So if you have e to the square root of x, can you do that? That would be e to the x to the 1/2. That's still not the same thing, because you're thinking of, like, it's not, like, you can't just multiply these here, because that's not what that's saying. It's e to the x to the 1/2. Like, this is separate. What we were doing was problems like e to the 1/2 x. We were writing that as e to the 1/2 raised to the x. There's a difference. You guys see? Subtle, but there's a difference. All right. So anyway, going back. All right, so I have the 4th root. So I'm going to do natural log of the 4th root of x squared plus 1 over x squared minus 1. So that allows you to pull the 1/4 to the front. Like that. Now what else can you do? But be careful, because it's really lit like this, right? You guys understand that? The 1/4 goes to both of them. So I'm going to write it that way. So I'm going to say natural log of y equals, yeah, thank you. Shadow guess gets a point. They get bonus points for correcting me.
Next time,
Yeah. All right, here we go.
All right, then.
All right, he fits in well with you guys. All right, take the derivative. So 1 over y dy over dx equals 1/4 times 1 over x squared plus 1 times 2x, right, the chain, minus 1/4 times 1 over x squared minus 1 times 2x. Yes?
Sorry to ask you again. I'm still confused with the 1 over y and the dy over x.
Okay, it's the implicit differentiation. I think you weren't here that day. Yeah. That explains a lot. Okay. It's section 4.2. 4.2, guys. So we need to do that.
Yes.
So if it's a y term, you always have to tack on a dy over dx, like the y prime.
Oh, yes.
Okay. All right, so we're going to reduce out. So 2 and 4 makes 2. 2 and 4 make 2 on the bottom. Right, so I'm going to get dy over dx equals y times x over 2, parentheses, x squared plus 1, minus x over 2, parentheses, x squared minus 1. Yeah, they could like do common denominators or something strange, which they usually try to make it as compact as possible.
Wait, what? Oh.
Okay, we good? You guys want any more? So what about like if I had a number 4? I don't have a number 4, do I? Y equals x to the sine of x. Yeah, I'm going to add a page. X to the sine of x. Yeah, y equals x raised to the sine of x. What if you have that? So notice how you have an x raised to something with an x. So you would have to do this logarithmic differentiation.
So, log of both sides. Natural log.
Mm-hmm.
And then you can bring sine x.
Yep. So your whole point is to be able to drop the thing that had an x. All right, now we're ready to take the derivative. So the derivative of natural log of y is 1 over y dy over dx. The derivative of sine of x times natural log of x involves the product rule. First times derivative of the second plus derivative of the first times the second. Yeah, like you're going to multiply the y over, is that what you're saying? So dy over dx equals sine of x over x plus cosine of x, natural log of x, which they could also have natural log of x raised to the cosine of x times y. Think like an AP writer. Those tricksters.
I'm trying to get
All right.